Okay, now our today's next discussion, that is, I have changed the topic rather, combination of a lens and a mirror. I have changed the topic. Alright, and I am going to discuss three cases. First, which has been asked in the CBSE 2014. This is the second case, which is also helpful. This is the third case. Only these three cases, if we discuss, I hope it will be sufficient. Now, I am talking first about this question here. Look, here the question is, in the year 2014, this is the figure, and the question is, a convex lens is placed in contact with a plane mirror. A convex lens is placed in contact with a plane mirror. L is for lens, M is for mirror. Okay. An axial point at a distance of 20 centimeter from this combination. Okay. It is said that at the distance of 20 centimeter from this combination, 20 centimeter from this combination here. Okay. An object is placed right here, this combination. An object is placed whose image is coinciding with itself. Its image is coinciding here. That means, how can you say that it will be coinciding? You can say that if you place a optical pin here, then its image will also be formed like this. Here only, at this point. Means this is the object and its image, if you see, it will be coinciding here. It is said in the question that it is coinciding here at this point. Then simply it is said that you find out the focal length of the lens. The question is find the focal length of the convex lens. I hope you understood the question. It is the question of CBSE 2014. I repeat, there is a combination of the lens and a mirror, and an object is placed, P is placed at a distance of 20 centimeter from this combination, and it is said that when it is placed at a distance of 20 centimeter from the combination, the object and its image both are coinciding. Okay? If they are coinciding, then the figure must be like this. Here, the ray from the object, always the rays will go, and definitely after being reflected ultimately, first diffraction, then reflection. Okay? Two things are happening. One is the refraction through the lens, another reflection by the mirror. Again reflection by the mirror, and again finally refraction by the lens. First diffraction, then reflection, okay, and after that again refraction, and it is coming here. How it is possible? To make it more clear, to have its more clarity, I am drawing this figure. To make it more clear, I am drawing this figure. I am saying that if suppose this mirror is not touching a bit distance, then you can understand what will happen. It is possible only, the ray will retrace only, means retrace, it is called the retracing of the ray only, if this ray will be falling ultimately at the normal incidence on the mirror. Only the rays which are incident normally, at normal incidence on a mirror, they only retrace their path. So it will retrace its path only like this. It is retracing its path. Then what happens? This will go like this. Definitely after that it will go parallel like this, parallel rays in this way, going and falling on this. Right? Yeah. What will be happening? पहले ये इस पर फॉल करेगा और फिर वो रिट्रेस करेगा. रिट्रेस करके again, if these are parallel rays, then definitely they will be focused here. This must be the focus. P must be the focus. That's why what will happen? F is equal to 20 centimeter. Focal length will be 20 centimeter. It is only possible when the focal length will be 20 centimeter. That means if the object is placed at the focus of this lens, then only it is possible that its image will be again formed at the same point. Understood? This is a direct question. Now, the same thing, more or less the similar thing I am getting in the second case. Second case is useful in solving a question. And you will see in the NCERT, the Ray Optics and Optical Instrument chapter, the last question. I hope it is 9.38. That question, this case will be helpful to solve that question. That question has also been asked in the board examination, and in the assignment I have given that question. You will see once. In that question you will see here, it is what happens here also the same thing. Here there is a mirror, plane mirror, on that there is a convex lens is placed. Okay, and just here the convex lens is principal axis, and if we just suppose the lens is placed, and if we take the object pin, in lab object pin, if we raise it like this is the object pin is raised in this way, a stage will come at the point P. What happens? Its own image will be formed here. You can see its inverted image through the reflection. You will look into this, and due to the reflection you will see its own image. How it is possible? Whenever its own image is formed, that is always due to the retracing of the rays. How it will be retraced? The same thing is happening. The same thing is happening. Here also the ray is coming like this. It is falling here, again retraced. Falling here and retraced. Okay, and there. That means this is also the focus. Here, this is also the focal length. Understood? Look. You will see that in that question. Now you are now knowing about this particular point. Now you just see that. You can see there. It will be the same. That is, this is the focal length. Wherever you are getting the inverted image of the same object, this is the object pin. Its inverted image. Dotted one is the inverted image. Obviously, it is indicating its focus. So this is its focus. Followed? That means these two cases are almost identical. And now we are coming to the third case. I just tell you, the third case is also the board question in the year 2016. It has been asked. CBSE 2016. CBSE 2016, I write here, CBSE 2016. This has been asked. What is this question in this? It is said that there is a combination of the convex lens of focal length small f and a convex mirror of radius of curvature capital R. They are placed in combination with each other. Alright, combination with each other, and it is said that here this object, its own image is formed here. Again the same thing. Here is the coaxially they have been placed. I repeat the case. There is a convex lens of focal length small f. There is a convex mirror of radius of curvature capital R. Right, they are placed coaxially like this as shown in the figure. They are placed in this way. Followed? So they have been placed in this way, and it is said that here when they are placed at a particular distances, it is said that its image is here, its own image is formed. Obviously there should be some distance, at some distances they will be kept, then only it is possible, right? Then what happens? It is asked, you redraw the figure. It has been asked to redraw the figure. So how to redraw the figure? You have to draw the diagram, means the ray diagram. Redraw means draw the ray diagram. Look, the ray diagram will be so that here is the object pin and its image pin. Here its image will be formed. How it is possible? The ray will go like this, okay, and it will fall normal incidence here. Again the ray will go like this, it will fall at the normal incidence like this. Look, normal incidence. And when it will be falling at the normal incidence, then only it will retrace its path and its inverted image will be formed. Look, am I clear? This ray from the point objects, the rays will go like this. It will be falling on this normal incidence. Here also it will be falling at the normal incidence, retrace their paths. And now what will happen here? Now I will take it like this. And it will also be produced straight. What will happen? This will be definitely the center of curvature, because you know here it is falling normally. Normally, if it is produced in the straight same direction, then it will be the radial direction. Because you know radius is always perpendicular to the tangent. It will be the radial direction. So what will happen? What will be ultimately R? R will be this value. My mark it here. Look, this will be the radius of curvature. Agreed? I hope all of you understood. This will be the radius of curvature. It is retracing its path, then this must be the radius of curvature. This will be the ray diagram. Alright, this is in our practical also. This case is there in our experiment also. When the practical classes will be held, you will see this case. Could you follow? Alright.